Hello, math friends. In this video, we're going to be talking about, we've practiced multiplying and dividing fractions and decimals. Now, what if they're negative? So we're just applying our negative rules to our fractions and decimals, like we've done before. So we're in 2.4 of your Unit 2 packet, so make sure you're open to that page. You got a pencil? Let's get going. Woo! Okay, so like I said, we're in 2.4, so make sure you are on that page. Okay. Whoops. Move me. Here we go. So like I said, all we're doing is we're taking our integer rules and applying it to rational numbers. So we're going to say I can apply integer rules to rational numbers. I got it to fit that time. Woo! That's a big success, guys. Big win. Okay, so we're just going to recap our rules that we learned. So when you're multiplying, you're just going to multiply the fraction or decimal like you're supposed to. Nothing about that has changed. Then if they have the same sign, and we're multiplying, so we're multiplying two positives or we're multiplying two negatives, then the product will be positive. So same sign is positive. If they have different signs, so a positive times a negative, or flip it, a negative times positive, so they have different signs, the product is negative. So same sign is positive, different sign is negative. And the nice thing about multiplying and dividing is that the rules for multiplying are the same as the rules for dividing. So same thing. When you're dividing, just divide the fraction, divide the decimal like you're supposed to. Then if they have the same sign, there we go. Then the quotient, this should say quotient, will be positive. And if they have different signs, the quotient will be negative. Cool. So that's super nice, right? Like we had to remember, okay, if I'm adding, take the bigger number minus the smaller number, keep the sign of the bigger number. If we're subtracting, we're going to change it to addition, and then if they're the same sign, we add them. If they're different signs, we subtract. Multiplying and dividing, if they're the same sign, they're positive. If they're different signs, they're negative. Bam. Okay, so let's do a few together. So, negative 3/2 times 9/10. I'm just going to make it bigger and zoom in so I can write better for y'all. Okay, so first I'm just going to multiply like normal. Remember, if it's a fraction, to simplify. So 3/2 times 9/10. 3 times 9 is 27. 2 times 10 is 20. Okay, they don't share anything. 20 is even. 27 is odd. Can't divide by 2. 20 is not divisible by 3. So it's just going to stay like that. And then I have a negative times a positive. Those are different signs, so my answer is negative 27 over 20. Okay? So, to multiply fractions, we do top times top. 3 times 9 was 27. Then we did bottom times bottom. 2 times 10 is 20. Then I had a negative times positive, so my answer is negative 27 over 20. And I'm fine if you leave it as an improper fraction. All right, 5/6 divided by -2/3. I'm going to start by rewriting 5/6 divided by, we're just going to deal with the numbers, okay? We're going to keep the first fraction, switch division to multiplication, then flip the second fraction, so 3/2. Okay, then I'm going to multiply across, so top times top, 5 times 3 is 15, over 6 times 2, bottom times bottom, is 12. And I'm going to reduce first. I see that 15 and 12 are both divisible by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. Then I have to figure out, should it be positive or should it be negative? Well, I have a positive divided by a negative. Those are different, so my answer is negative. So -5/4. So all I did was I turned division to multiplication. I kept the first one. I switched to multiplication, and I flipped the second fraction. We got 15/12. Then I had to reduce. So 15 divided by 3 is 5. 12 divided by 3 is 4. So it became 5/4. One is positive, the other is negative. When we're dividing different signs is a negative. So -5/4. All right, some decimals. So we're going to multiply like normal. We're going to pretend the decimals aren't there for a second. So 4, 3, 5 times 2. Okay, 5 times 2 is 10, carry the 1. 2 times 3 is 6, plus that 1 is 7. And then 2 times 4 is 8. Okay, then I'm going to count how many numbers in my problem are after a decimal. There's 1, 2, 3. So starting at the end, we're going to go 1, 2, 3. And that's where my decimal goes. And then figure out if it's positive or negative. I have a negative times a negative. Those are the same sign, so it's going to be a positive 0.870. So I just multiplied the numbers together without the decimals, and I got 870. Then I counted that there's 1, 2, 3 numbers that come after a decimal in the original problem. So I started at the end of 870 and I went back 3 spaces. That's where my decimal point went. It's a negative times a negative. Those are the same sign. So my answer is positive positive 0.870. Okay. So -16.5 divided by 0.25. Remember, the 16.5 goes in here. Okay, then working on the outside number, I need to go 1, 2 spaces so that my decimal point comes after the numbers. And I need to do the same thing with the number on the inside to match the outside movement. So 1650 is what we're now dividing. Okay. So 25 does not go into 16. 25 can go into 165. So 25 times 4 is 100. If I added 25, that would be times 5 to get 125. 150 would be times 6. And then 175, oh, that's too big. Okay, so I'm going to go with times 6. So 25 times 6 is 150. Okay. So then now I have 165 minus 150. Okay, so you're left with 15. This 0 comes straight down. Oh, and that's super nice. We already found out how many times 25 goes into 150. So 6. We're left with 0. My decimal point is here, so it's going to go straight up here. I'm going to get rid of this scratch whip real quick. Okay, so now that I have found my answer, okay, a negative divided by a negative, they're the same sign, so my answer is positive 66. So we took our original problem. I had to move the decimal point out of the divisor, so the number on the outside. And I had to match that on the inside in the dividend. Okay, so then it became this, and then I found that it was 66. And a negative divided by a negative, they're the same sign, so my answer is positive. Okay, and I just want you real quick, when they talk about a compound fraction, they look super scary, but they're totally not. So a compound fraction is a fraction within a fraction. So like 2/3 over 5/4. Remember that a fraction bar is just division. Okay, so this is 2/3 divided by 5/4. And then it's a lot less scary, huh? And then we can do that, right? We keep, switch, flip. So keep the first fraction, 2/3, switch to multiplication, and then flip the second fraction. So 4 over 5. 2 times 4 is 8. 3 times 5 is 15. 8 and 15 don't share anything, so that's it. Okay, so a compound fraction. Or if you saw like that, 2/3 divided by 3, you could do the same thing. Okay, it's just a fraction within a fraction. I always rewrite them as the division side to side. So it's a little less confusing to look at. All right, so for your practice, this is what we're doing. Pay attention on each level. If it says to do all of them, if it says to do 3, if it says to do 2, whatever it says. Pay attention to the instructions. Make sure that you multiply or divide the fraction like normal, then figure out the sign. Same thing with decimals. What else? Oh, if it's a fraction, make sure you reduce your answer. So, you guys are doing great. Have a great day. Bye.